Dear students, we'll continue with our chapter Surface Chemistry. Today we'll discuss few things about the preparation of colloids. So the number one method is called chemical method. Okay, so by the chemical reaction we can prepare the colloids. One example is AS2O3 plus 3 molecules of hydrogen sulfide, double decomposition reaction. Okay, the exchange of ions takes place, so it forms a Sol of As2S3 plus 3 molecules of water. This is one of the example. And other example we can take is a sulfur Sol. Okay, here sulfur dioxide is treated with 2 molecules of hydrogen sulfide. Okay, this is the oxidation reaction, so sulfur Sol, 3 molecules of sulfur. Okay, so sulfur Sol is been formed. Similarly, gold Sol can be prepared like 2 AuCl3 plus 3 HCOCl. This is your formaldehyde plus 3 molecules of water. On reduction, it gives gold Sol, right? Similarly, ferric hydroxide Sol can be prepared from ferric chloride when reacts with water, 3 molecules of water. So this is known as hydrolysis. So ferric Sol, FeOS thrice. So ferric hydroxide Sol is formed. Similarly, another method is called electrical disintegration or Bridge-Arc method. Okay, in this method, what we'll normally do is we'll have this 2 rod. Right? If we want to make a gold Sol, then it should be a 2 gold rod, right? Then one is connected with a high voltage positive, another is negative terminal of high voltage. Then it is dipped in a dispersion medium, and this whole thing is kept in a ice bath, right? So when it positive rod touches with negative rod, what we see is a spark, right? So during the spark, now the spark is taken inside the dispersion medium. So during the spark, some of the ions, okay, some of the atoms will disintegrate from this rod, okay, and it forms a colloidal particles. If we have a gold, then it will be a gold Sol. If we have a platinum, it will form a platinum Sol. Then another important term is peptidization. What is peptidization? So peptidization may be defined as the process of converting precipitate into the colloidal Sol by shaking it with dispersion medium in the presence of a small amount of electrolyte. Right? So if you have a precipitate and if you want to convert it into colloidal solution, then you have to dissolve with the suitable electrolyte, right? You have to dissolve in a suitable medium, dispersion medium in presence of suitable electrolyte. Then it becomes a colloidal solution. So in this case, what happens is that precipitates gets attached by that electrolyte ion. Okay, either all positive or all negative ions gets absorbed. Then it will come again to the solution as a colloidal. Next is purification of colloidal solution. So it can be done by dialysis. Now what is dialysis? It is the process of removing dissolved substances from a colloidal solution by means of a diffusion through a suitable membrane. Now we can have a look at this picture. So the continuous flow of water is there. So it's a water intake, a water is going out from here, right? And we have this container which has a semi-permeable, which is made from semi-permeable membrane, right? So it is called dialyzing membrane, and inside this we'll add a colloidal solution. So what will happen? Remember, the dispersion medium must be water here. So what will happen is that water comes from here and it will go inside this bottle, and since it is a semi-permeable membrane, so that allows the dispersion medium to pass through it, whereas dispersion phase, that is the colloidal particle, cannot pass through this semi-permeable membrane. So the water will go inside it, okay, and whatever the impurity is there, so it gets removed and it comes out along with the water. Okay, so small impurity that comes out with this semi-permeable membrane, the dissolved impurities normally. Now the process of this can be speed up, so that is known as electrodialysis. You can refer it here. electrodialysis. In this case, what happens is that we have same arrangement here, but we'll add one to rod here. Okay, this plate. One is positive plate, is called anode, negative plate cathode. So what happens is that we know that colloidal particles are always a charged particle, right? And impurity, if it has a impurity, that is electrolyte, maybe it may have both positive or negative. So these electrolytes, impure electrolytes, get passed through this semipermeable membrane. So positive ions will move towards the cathode, negative ions will move towards the anode. In this way, the dialysis will be fastened up. So this is known as electrodialysis. Then another technique is known as ultrafiltration. So you know the ultrafilter paper. So it is a special type of filter paper that is prepared by soaking the ordinary filter paper in a collodion. That collodion is made from a 4% solution of nitrocellulose in the mixture of alcohol and dry ether. Then the filter paper is hardening by formaldehyde, and then finally it is dried out. Then that filter paper is known as ultrafilter paper. So we know that we have already learned that colloidal particle do not pass through ultrafilter paper. So we have to filter that colloidal solution. Then we'll have that dispersion phase in the filter paper. Then we'll wash out this first phase with the dispersion medium. Then whatever the remaining impurities are there, that will be removed. Now the properties of colloidal solutions. So number one is it shows colligative property, but it has a smaller order as compared to the values shown by the true solutions of same concentration, because a colloidal solution normally is formed by the aggregates of the particle. Another important properties of colloidal solution is Tyndall effect. Now here you can see the diagram. Here we have a colloidal solution here, and we have a white light source. Okay, we have this lens that will concentrate our light. So it's a white light, right? So when white light is passed through this solution, what we obtain is that if we view from the 90-degree with the light of the path, so this is the light of the path. So if we view from this angle, it looks like a bluish line. We see a bluish color. But from here, if we see from here, okay, we see a red color. The basic condition to show that effect, a Tyndall effect, is number one, the diameter of the dispersed particle, that is the colloidal particle, is not much smaller than the wavelength of the light used, right? Number two, the refractive indices of the dispersed phase and the dispersion medium differ greatly in magnitude. Then only we can see that Tyndall effect. That is, when we view from the 90-degree angle of the path of the light, we see a blue color, and from here then we see a red color. Another important properties of colloidal particle is Brownian moment. Now what is Brownian moment? It is the continuous zigzag motion of the colloidal solution. So when we keep a colloidal solution in a container, it has been noticed that the colloidal particle do not settle down. Okay, the particle are continuously in motion. So this was first this type of motion, Brownian moment, was first observed by the British botanist Robert Brown. Okay, and he's given the name Brownian moment. Actually, he first observed that thing in a pollen grain. So he kept the water in a container. Okay, then he poured some pollen grain in above the water. So pollen grain floats in the water at the surface of the water, and the pollen grain keeps on moving in a zigzag motion at the surface of the water. It never comes to the rest, right? So it has been said that why this zigzag motion? Okay, what is the basic principle, or what force is behind that zigzag motion? So it has been said that the dispersion medium, or here in the water, so water molecule is continuously bombarding that pollen grain. Okay, so pollen grain is moving from here to other place. Okay, so same applies here also. In colloidal solution, the colloidal particle is continuously bombarded by the solvent molecule or the dispersion particle from the dispersion medium, right? So that's why the colloidal particle keeps on moving randomly in a zigzag motion. Next is the charge on colloidal particle. So normally in lyophobic colloids, not in the case of lyophilic, in lyophobic colloids we observe that colloidal particles have same charge. All the colloidal particle, that means a colloidal particle in a container will have either all positive or all negative charge. Now which charge the colloidal particle will acquire, whether that is a positive or negative. So one of the rules says that the preferential adsorption of ion common to the colloidal particles usually takes place. Okay, look at this equation. AgNO3 silver nitrate reacts with potassium iodide to form silver iodide sol. This is a solid particle precipitate, okay, plus KNO3. So it can be prepared in two ways. So I'll take this as case 1. So case 1, Ki is in the container. We have Ki in a container. Okay, it exists as a K plus and I minus. And silver nitrate, we are adding silver, few drops. Remember the few drops of AgNO3 aqueous. So it is also Ag plus NO3 negative, right? So we'll add. Now what will happen? Whatever the amount of AgNO3 we have added, it gets consumed. So what remains inside this container is, it already has K plus I negative, right? Because there is plenty of K plus and I negative. Then we have added AgNO3. Now Ag, whatever we have added, that will react. So Ag will add up to I, so it will form AgI. So another component we can see is here AgI, and NO is also added. So this act as a, since this is a solid, okay, is a particle, then remaining, then we add NO3 minus, right? So what are the things inside the container is K plus I minus, because there are plenty of K plus and I minus, and we are adding few drops of AgNO3, right? So Ag gets easily attached to I, so it forms AgI, and NO3 remains as a NO3 negative. Now this is your sol, or we can call it colloidal particle. Now as per the rule says, it says that the common ion to this colloidal particle gets absorbed, right? So you see, what are the common ion present here? So it's Ag is there? No Ag is, because Ag, whatever Ag, it gets consumed and it forms AgI. Then NO3, yes, NO3 is there. And so Ag is there? No. I is there? Yes, I is there. So that means here in this way it forms AgI attached with I minus. So it gets iodine gets absorbed, iodide gets absorbed. So it is a negatively charged sol. Negative sol. Alright. So it forms a negative colloidal particle. So remember, Ki is there, and if I add AgNO3, then negatively charged sol is formed. But in other ways, right? Case 2. So the container already has AgNO3, so that means Ag plus and NO3 minus. Then we are adding Ki, right? So Ki, so K gets here. So here again K ion will be there, K positive, and I. So I easily gets react with Ag, so it forms AgI. So AgI is a solid because it's insoluble in water, right? So AgI. So AgI is a solid. Now look at the common ion. I is present here? No, there's no ion. Ag is present here? Yes, Ag is here. So AgI it gets attached with Ag plus Ag plus Ag plus Ag plus. Okay, there are many numbers, so that means now this is your positively charged, positive soul. So okay, so when Ki is added to here, so see, this reaction takes place, right? So this is a Ki plus AgNO3 reaction. So this is soul has been formed. Okay, so whatever I is used, so whatever Ki has been added, so I is used as a Agi. Fine. So K will remain as a K plus only in the solution. So now this is our soul. Now do you have to look for the common ion? I is there? No I. Ag is there? Ag. So it forms. So the same reaction, we are preparing the negatively charged colloidal particle. Colloidal particle is Ai. It gets adsorbed with I minus, right? So it is a negatively charged. So Ai is a colloidal particle. It gets attached with, it gets adsorbed with Ag plus ion. So it gets a positively charged. So in this way, the colloidal particle gets charged. One more thing in this case is this is called a primary layer, or it's a fixed layer, right? Now there is another secondary layer also may be there. So this is the primary layer and secondary layer. So this is negative, then which is positive? So K plus. So K plus will be your secondary layer, right? So this is called mobile layer. Mobile layer. In here, what will be the negative ion? This is a plus, then it is a negative. So it's a NO3 minus. So NO3 minus, NO3 minus. Now this is mobile. This comes here and goes. Okay, it won't be fixed. But Ag plus is a fixed. So this is called primary layer, secondary layer. Primary layer is a fixed layer and secondary layer is a mobile layer. And there is a potential difference between this positive and that is a primary layer and secondary layer is known as electrokinetic potential or zeta potential. So what is that? That is the potential difference between the fixed layer and the diffuse layer, the secondary layer. Next important term is electrophoresis. Now what is electrophoresis? Electrophoresis is the movement of the colloidal particle towards the oppositely charged plate is known as electrophoresis. Okay, the movement. So we can see there is a positive charge anode, negative plate, charged plate, cathode. Now if we have this negatively charged soul or colloidal particle, that means it will move towards the positively charged plate. Okay, so what will happen is that it will go and it gets attached and it gets discharged. All the charge gets discharged, and once the charge gets discharged, it gets coagulate and settle down as a precipitate. So the movement of the colloidal particles towards the oppositely charged plate is known as electrophoresis. Now what are the techniques to precipitate the colloidal solution? So number one is by electrophoresis. Already we have said, right? When gets attached to the oppositely charged plates, it gets discharged and gets discharged and it aggregates together and settle down. Now by mixing two oppositely charged soul, like in earlier case example, AgI case example, if we have an equimolar component of AgI with positive charge and AgI with negative charge, if we mix them together, then they will settle down, because the primary layer, you can see here AgI is the primary layer, Ag is the primary layer, I is the primary layer here. So this Ag reacts with I and again it forms a AgI. Okay, so in similar way all the charge gets discharged, then the coagulation takes place. Then sometime boiling also, and sometime persistent dialysis. We have already learned dialysis. Dialysis means we have already discussed, if prolonged dialysis is done, then what happens is all the charged particle which gets attached to the colloidal particle, that also come out. Okay, and then the colloidal become chargeless, then they aggregate together and settle down. Similarly, by adding a suitable electrolyte. Another important term here we have to learn is a Hardy-Suzel rule. It says that the greater the valence of the foculating ions added, the greater is its power to cause precipitate, right? So here we can say the the power of precipitating the negative ion is aluminum, then comes barium, then comes sodium ion, because you can see the charge here is on simply 1 plus, 2 plus and 3 plus. That's why it has a maximum charge. That's why it has a more power of precipitating the negative soul. Similarly, in case of precipitating a positive soul, you can take this as, because it has a 4 negative, okay, yeah, phosphate 3 negative, sulfate 2 negative and chloride negative, single 1 negative. Next is emulsion. Emulsion means it's a liquid colloidal system. Here the dispersion phase is also liquid and the dispersion medium is also liquid, and it is of two types. Emulsion are of two types. Number one, oil dispersed in water, we write as a O/W type. Another is water dispersed in oil, W/O. Okay, the example of oil in water is milk and varnishing cream, whereas the example of water in oil you can take as a butter or cream. Now the colloidal around us, we can see the blue color of the sky, that is due to the dust particle that is suspended in the air. So this is scattered blue light, that's why we see a blue light. Fog, mist, rain, so you must have noticed that when the light is passed through the fog, you can see the light, path of the light. Similarly, food particles, milk, butter, these all emulsion we have already talked. So this comes under the colloidal part. Blood is also a colloidal solution of aluminum substances. Swell. Okay, then another important is the formation of delta, right? So there is one question, that why the delta is formed at the junction of river and sea water. So why delta is formed at the junction of sea and river water? The answer is that river water contains a colloidal or solution of clay. Okay, so river water has a colloidal of clay, so it has mud and all. So sea water contains number of electrolytes. You know, sea water is our in test, right? So it has number of electrolytes, salts, right? When river water meets the sea water, the electrolyte present in the sea water coagulates the colloidal solution of clay, resulting in the deposition with the formation of delta, right? So seawater has a lots of electrolytes. So when electrolytes it comes in contact with the colloidal solution, that is clay, so whatever the charge the clay has, it gets neutralized, and as soon as it neutralizes, it gets coagulate. Okay, they aggregate together and coagulate, means precipitate, and they settle down at the bottom. Now we'll discuss a few application of colloids. Number one is it's called Cottrell smoke precipitator, right? So normally this is fitted in a top of the gas chimney in the factories normally. So you can see smoke is coming here. This is a high voltage electrode, a plate basically. Now remember, this plate is of negatively charged whatever the smoke particle has. So is oppositely charged whatever the smoke particle. If these smoke particles are in positively charged, that means this electrode is of negatively charged. If the smoke particles are of positively charged, that is colloidal solution, we know it's a charged particle, then it is a, if it is a negative colloidal smoke is of negative, smoke particle is of negatively charged, then electrode, this plate is of positive charge. Now what happens is that when the smoke will come to this contact in this plate, it gets discharged, then it gets settled down. So here is the collection of ash. So in this way, so after that the gas comes out. So whatever the particle present in the smoke of the factories, that will be left out here, and only the pure gases which are free from the carbon particles, this comes out from this smoke precipitator.